This lecture is on salmon and orcas, and it's sort of part 2 of the herring lecture. So herring being that foundational forage fish which are consumed by salmon, which in turn are consumed by orcas. The salmon section here is relatively brief, but just to show that we've got 5 major species of salmon. The first here is pink salmon or humpy salmon. Pink salmon are really interesting. They can be really numerous. They spawn in the lower reaches of rivers, and they have a really short lifespan. They only live for about 2 years. Or they only live for exactly 2 years. And in Washington, our pink salmon runs are really large on odd years, and on even years, they're really, really small. In Alaska, it's the opposite. In Alaska, the even years tend to have a lot of pink salmon, or the odd years tend to not have a lot. And they're in the hierarchy of salmon people want to eat. Pink salmon are typically the lowest. You wouldn't go in a restaurant and see a pink salmon typically served. However, smoked, they're quite good, and there's some canned pink salmon products that are pretty good. The next one, let's go over to coho. Coho and Chinook are pretty similar. Coho in particular, anyway, can have 2 major juvenile life history stages. One is when the eggs emerge from the gravel. The smolt or baby salmon can go straight out to the ocean. The second one, they actually stay in the river for a full year and then grow up and then go out in the ocean at a larger size. They typically live about 4 years, 3 to 5, and then return to spawn in their natal stream. Chinook or king salmon have a very similar life strategy. They can do the same thing as well. Some are the ocean type where they'll emerge from the gravel in the spring and then by fall migrate out, or they might stay in the freshwater for another year. The advantage of staying in freshwater is there's less sharks, so you're less likely to be eaten. The disadvantage is food becomes more limiting. There's a lot less food available in the freshwater systems compared to the marine. So these fish are kind of facing that choice of stay in the freshwater where it's nice and safe, but there's less food, go out in the ocean, face the sharks, and potentially have more food. Chum or dog salmon are kind of similar to pink or humpies in that they spawn in the lower reaches of the river. They don't go very far up rivers. There's a couple exceptions to that. One is the Yukon River fish, but in general they kind of be a little bit of a lower river spawner. They're pretty tough. They can occur in really small streams where other fish don't. For example, Paddon Creek has some chum salmon that return, but no other salmon species, and so they can use really small kind of marginal habitat for a few fish to go in and spawn. Their name chum and dog salmon, their common names, don't really make them sound all that appealing, and this was an issue as particularly the 3 species people really like to eat, sockeye, Chinook, and coho, have started to dwindle. That there's still a lot of coho, and they're trying to still a lot of chum, and so trying to figure out a way to market it. So now in the market, chum is called keta, or sometimes called kita, but keta, K-E-T-A, which is kind of funny because that's actually the species name. All Pacific salmons are Oncorhynchus, is the genus, and then keta is the species name for chum. So instead of, and they actually sell it down at Anthony's home port. Anthony's, you can spend $25 for a plate of chum salmon, and likely people don't want to spend $25 for chum, but they'll spend $25 for keta. And there's a nice description about how great it is. I think it's great. It's a different fish. It's my favorite fish for smoking. I usually get a bunch of chum salmon in the fall. They run later in the year, kind of October around here. and then I'll smoke a whole bunch with the whole fillets. The fifth Pacific salmon are sockeye salmon. Sockeye salmon are really interesting. They have a pretty strict 4-year life cycle. Like chum, coho, chinook, they kind of range between 3 and 5. Sockeye are really tight on a 4-year time cycle. And sockeye only spawn in creeks associated with lakes. That they go up to a creek, lay the eggs, they fertilize, they hatch out of the gravel, and then the fry, the juvenile salmon, live in the lake for a full year before they leave. So because of this, they're in the fewest number of streams because they're bound to streams with lakes associated to them. But when they do occur, they tend to occur in massive numbers. So locally, the Fraser River is a massive sockeye run. It's pretty interesting. The Fraser has a interesting 4-year cycle. So again, these fish live for 4 years, but there's fish spawning every single year. So you would think that returns are more or less the same from year 1, 2, 3, and 4. But it turns out the Fraser has this 4-year cycle, and based on sediment work in lakes, looking at scales and nitrogen content from the salmon returning, this cycle has persisted for at least a few hundred years, where every 4th year it's a massive sockeye return. And sockeye are the main species that the reef nets are targeting. And so because there's not a lot of salmon-bearing streams in the San Juan Gulf Islands, but you have all of these sockeye passing through the islands going up to the Fraser River, reef nets are this great way of capturing those fish. In general, in the salmon world, for the longest time, all salmon issues were sort of thought about around these 4 things, the 4 H's: harvest, habitat, and hatcheries. Meaning, if you want to understand salmon populations and what's happening, you need to understand harvest. How many fish are we collecting and gathering through fisheries, and then other predators. Habitat, they need habitat to spawn in. Hatcheries, hatchery wildfish interactions. There are some decent ones and there are some bad ones. Hydropower and other dams being a big issue for salmon habitat and spawning area. So for a long time, these were the 4 things that everybody thought about. And then about maybe 15 years ago, people realized, oh, wait a minute. All of these are more kind of freshwater oriented. And these fish come in the freshwater. It's really important. They spawn. And then they come out of the gravel and they leave for a couple of years and they come back. What happens when they're gone might matter. And so the ocean conditions began to matter. And people started to understand and think about what's happening to these salmon when they're out at sea. Do they have enough food? Is there different interactions that are going on? So that's the oceanography, as it relates to salmon, has recently become, it's always been important, but it's recently been recognized as being important. This is looking at the total abundance of Chinook salmon or king salmon returning to Salish Sea rivers. Looking at the just straight number starting from 1984 to 2010, you'll notice a slight trend here that the total abundance has been decreasing, and this is abundance of both fish that survived into the river and then fish that were caught. So we've been seeing declines in salmon abundance. The next question, of course, is what does that due to? Is that habitat issues? Is that an oceanographic issue? What can we do to help change this trend? And this is a cool project called the Salish Sea Survival Project that's interested in what happens to salmon as they leave this area and what factors are important for predicting the survivorship of salmon. So all these graphs are looking at survivorship as a percentage. And so once fish leave, become smolts, and they enter the marine environment, what's the percentage that are likely to come back? And you can see here, based on these data, they kind of bounce around a fair amount, but in the 70s, relatively good percentages of returns, and some of these, 10-12% survivorship. That's huge. Salmon lay a lot less eggs than herring. So herring, we talked about 20 to 40,000 eggs per fish. Here it's more on the order of like 1 to 2, maybe 3,000 eggs. Much fewer eggs, but they're much larger, so there's a greater investment per egg. And these fish are spawning and dying, so they only get one shot at this. And their salmonid survivorship tends to be much, much, much higher than marine fish like herring. And one of those reasons is they're found a safer spot for the eggs. The eggs are being laid in streams that have a lot fewer predators. If you think back to the herring lecture, everybody's going after these eggs. There's much fewer predators on salmon eggs than there are herring eggs, and they're also buried under the gravel. They're not just out there for everybody to eat, but they have to overwinter. So they lay the eggs in the fall, and then the eggs hatch in the spring. So all that's to say is that one of the reasons we can have such massive harvests on salmon is that they're so productive. They lay a decent amount of eggs, but they have a high survivorship. 10-15% of survivorship is massive. But you can see more recently it's down to the few percentages. Chinook, and the scale is much different here in Chinook. So this is looking at, here the scales are 0 to 20. For Chinook it's 0 to 3.5. In the 70s and early 80s, a decent survivorship, and down into the mid-2000s, less than 1% of fish surviving. So that's been one of the big issues, is the fish just are not returning, that they're dying somewhere out in the ocean, that presumably food is becoming limiting for them. And this is in Puget Sound, Strait of Georgia, off the coast, in the coastal systems. There's been it's been variable. There's been some lows and some highs, but not really the same trend that we see in the coastal areas or in the inland areas. So one of the thoughts about this is that the Salish Sea itself is being impacted, where the open coast areas are being less impacted. So this could be an issue of anthropogenic impact, changes in water quality, things like that are impacting the survivorship of salmon. So those of you with the salmon timeline, this is a pretty interesting graph, and there's a link to it, to think about how many fish have been caught and what that looks like. And so these are data that go back pretty far. Most data don't go back to 1866, showing thousands of pounds of fish. These are fish that were caught or harvested in the Columbia River. And what you see is in 1866, not a whole lot of fish being caught. Now, there's a difference between the number of fish being caught and the number of fish that exist, right? This is fish that were caught, and this is reconstructed. You have to follow the link, but mostly probably reconstructed by export records, and so how many fish were canned and barreled and things like that. So in the 1866, not a whole lot going on, and then you see this rise in a pretty interesting pattern here through about 1880 through 1920 or so. There's a few things that are happening. One is the advent of canning, the advent of being able to catch fish, put them in a can, have them shelf stable, that doesn't require refrigeration. Great source of protein, lasts for a long time. 1800s, early 1900s, no refrigeration or freezing, so the ability to have good protein with good fat in a can is massive. So that becomes very economically and technologically important, and so the rise of salmon canning is this line right here. It's like straight up. Now these variations here could be associated with population. So this variation could be a good salmon return year and a bad salmon return year, if you assume effort was the same, meaning there's the same number of fish traps out and people out fishing. So that could be some evidence of interannual variation. Could be changes in effort as well. And then you can see that this amount of harvest was probably not sustainable, combined with the building of dams through this time. and then now we've driven the populations way down, and we see these kind of little bumps here. So massive changes. Oops. Hydropower being a big piece of that. Cooley Dam and these other dams that were created to kind of pull us out of the Great Depression also blocked off fish, and fish passage was not necessarily considered in most of those. There were laws that on the books that prevented dams from stopping salmon migration, but they weren't necessarily enforced. Or with the advent of hatcheries, then the argument was, well, we're going to cut off access for these fish, but we'll make a hatchery and it'll all just wash out and everything will be fine. Turns out that didn't really work out that well. So our friends, the orca whales. There are multiple different types of orca whales, and we're going to briefly talk about the southern resident killer whale. So you'll see SRKW, which is the acronym for Southern Resident Killer Whale. And they're obviously an iconic species and a species of concern here in the Salish Sea. And there's a few different types, but the kind of two main types of killer whales are the resident killer whales and what's called the transient killer whales. And they're different. It's interesting, they've been considered the same species for a long time, and they're likely subspecies, and they should be managed as such. They look different, they do different things, they eat different things, their social structure is different. The resident killer whales eat primarily fish, and of that, primarily Chinook salmon, where the transient whales tend to be marine mammal eaters, seals, porpoises, sea lions. The resident killer whales have a much stronger social structure. They form larger social pods, where the transient whales will be in smaller groups. They talk differently. The vocalizations of resident killer whales are a lot more. They're talking a lot more. Transient whales tend to talk a lot less, vocalize a lot less, because they're trying to go after other marine mammals that can hear them. So they're kind of more like a wolf pack, that they find one or two animals and they'll chase it down and eat it, where residents are talking more, chasing large schools of salmon. And in general, the resident killer whales have a much shorter range compared to transient killer whales. Although recently the residents have made some pretty good migrations, which is probably an indication that they're searching for food, where the transient whales can just get up and go and go long distances. Now this is an interesting graph to me. This is the number of orcas in the southern resident orca population. Take a minute and kind of think about this graph. It's from 1976 to 2017. One could argue, and I'll pose the argument, that there is no change in population. If we look at this, 1976, we're here. Yeah, sure, in the 90s there's a few more, but we're kind of back to where we're at. You could state that over for 45 years or so, orca populations, southern resident orca populations, have been stable. You could make that statement, and these data would back up that statement. So then you could say, well, why is there all this hubbub about orca whales? Population looks fine. They were here in 76, and they're about the same today. There's a little kind of, rise, but not huge, and then kind of back to where we're at. And so on the surface, you could make an argument that there's not a big reason for alarm. When you move in and look at a few different things and take these data in a greater context, then there could be some reasons for concern. First of all is the shifting baselines. And so we do not know how many orcas were here 200 years ago, 500 years ago. But this start of our graph at 1976 is likely a depressed population because the live capture industry had been going on for at least 10 years, killing many whales, capturing some more. In addition, the sentiment at the time was that orca whales were something that you should, particularly if you're out fishing and they get in your way or entangled in your net, they're a pest, they're a problem, they're something to be shot. If they get tangled in the net and die, nobody cares. They might even buy you a beer at the bar. Like, it's fine. So that is likely to depress the population. So if we're looking at the 1976 population as our baseline, as like our restoration goal, that's probably false, because we know that there are these other factors that would have led to a depressed population at that point. Two, if we look at the population dynamics, that to make more, and this will sound profound, to make more orcas, you need reproductive age females. The southern resident orca population has very few reproductive aged females. They have very few reproductive age females, and so the ability to make more orca whales is very limited. In addition, the ones that are being born are not surviving. So you have a population that's at a depressed level, has had some increases, which is positive, followed by decreases, stabilization, and some decreases. But the fuller picture of the story is there's not that many reproductive females available, and when they do give birth, those births have not been successful. We'll go through the numbers in short order, but to me it's really interesting to be able to look at a graph like this. You can certainly make one argument, and you can make another one, which would require some additional context. So looking at orcas by number, between 65 and 75, the live capture industry was pretty active for marine parks. In 1973, there were 66 southern resident orcas. By 95, that number had grown to 98, which is great. Last year, last available data, put it back at 74. Between 2007 and 2014, 2/3 of the pregnancies have failed. And between 2015 and 2018, 0 calves have survived. In fall 2018, there was 1 pregnant female in each pod, and there's been 1 birth that we know of in 2019. So these numbers are of major concern, and primarily this issue of pregnancies not coming to term, calves not surviving, and female orca whales aging out of reproductive age. The three southern resident killer whale pods. J pod has 11 adult females, 1 post-reproductive, 2 young females, 4 adult males, and 5 young males. K pod has 7 adult females, 2 post-reproductive, 1 young female, 6 adult males, and 4 young males. J pod has 14 adult females, 5 post-reproductive, 3 young females, 6 adult males, 11 young males, and 1 unknown gender. And one of the big issues, we'll talk about the 3 big issues here, but one of the big issues for decline, one of the concerns, has been the observation that orca whales and their babies are emaciated, that they're looking starved, they're looking thin, they're unhealthy, and when you get weak like that, when you're malnourished, other maladies are likely to come in as well. So if you're malnourished and sick, you're more likely, if you're malnourished, you're more likely to get sick from parasites and other diseases. Your body's more susceptible to infection, so you might not die directly of malnourishment, but that malnourishment will open you up for other issues. And southern resident killer whales eat a lot of Chinook salmon. 82% of their diet is Chinook salmon. a few percentage, was it 14%. Other types of salmon, 3% other. So they're really big time salmon eaters, and mostly Chinook salmon is by far and away the primary prey for southern resident orca whales. So as Chinook salmon populations are declining, it makes sense that species that rely almost entirely on Chinook salmon are also going to be suffering. So it's hard to get away from the fact that if you are a super predator like a orca whale and your prey base declines, that is not good for you. And that's been one of the main drivers of decline is lack of food. Disturbance has been, noise has been a big issue that a lot of folks are trying to look at more directly, and there's actually a movement now to see if under the Endangered Species Act, if noise can be considered a primary driver of decline, and there can be additional protections around noise. This is often attributed to both the whale watching industry and people kind of running up on the pods of orcas as they're trying to forage and feed and disrupting their behavior. Addition just to background noise from large cargo ships and tankers moving through the area. As a diver, I can tell you, you can be underwater and not even see, well, if you're on the surface, you can look around and not even see a tanker. If you're under the water, you can hear it, and you can feel just the sounds just hitting your chest, just woom, 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 woom. It's really interesting, and that's with crappy human ears, right? Like, that's not with the echolocation that orca whales have. So the noise and disturbance is a real issue, and it's really hard, I think, for us to understand because we are not listening at the same frequency. In addition, we rarely put our head underwater, but when you do, I mean, it's deafening. If you're in an area and a large cargo ship goes by, it's deafening underwater. And again, that's with my crappy human ears. Toxins have been a big issue, and again, as you move higher up the food chain, these toxins bioaccumulate. And so if you're thinking about some trace toxins in the water, those are making their way into the phytoplankton that the zooplankton are eating, that the herring's eating, that the Chinook salmon's eating, that the orca whale's eating. Each step in that chain, those contaminants get larger and larger and larger. They biomagnify through the food chain. And so orcas are getting by far the worst of it. And so just general toxins in the Salish Sea is a big issue. There's for sure a lot more about orcas. I encourage you to look up the Southern Resident Killer Whale Task Force. They put out a bunch of great documents. There are some links in this lecture to it. They're real experts on this. And there's some other organizations as well, but that task force has really put together some nice packets as far as easily digestible, what are the issues and what can we do about it. So Heishka, thank you.